Yeah, good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Yeah, today we are going to discuss about the complex numbers. Okay, na? So until then we have discussed about that surds, right? Rational and irrational numbers. Now complex numbers also. Let us see the complex numbers. What are complex numbers? What are called complex numbers? So complex numbers are nothing but if A and B are any two real numbers, A and B are any two real numbers, the A and B are can be expressing in the form of A plus IB. The numbers which are in the form of A plus IB are called complex numbers, where I is nothing but imaginary numbers. I is nothing but imaginary numbers. Okay, na? So for example, in our previous class we have discussed about that irrational numbers. What are irrational numbers? The numbers cannot be expressed in the form of P by Q are called irrational numbers. Example, if you take root 2, root 3, root 5 and so on like this, right? Such type of numbers are called irrational numbers. What are they called? Irrational numbers. Okay. Because while you are observing in the square root, value 2 and 3 and 5, these are all the positive numbers. Positive real numbers. In case, if they are taking root over minus 2, root over minus 3, root over minus 4 and so on, these are called imaginary numbers. Such type of numbers are called imaginary numbers. Clear? Okay. Now the complex numbers are nothing but if A and B are any two real numbers, then A plus B, the real numbers are of the form of A plus B are called complex numbers, and the complex numbers are represented with the letter Z. Okay, now. So the numbers which are in the form of A plus IB are called complex numbers. Then how can you write imaginary numbers I? That means we are writing this root over minus 2 can be expressed as root over minus 1 into 2. Root over minus 1 into 2, and this minus 1 we are representing with the letter I square into 2. That means if you write separately, before that we can separate the square root like this, root over minus 1 into root 2. According to the property of irrational numbers, root A into root B we can write as root over A into B. Same way, root over A into B we can write as root A into root B. Such a way, I can write root over minus 2 as minus 1 into 2, and I separated by using the product formula minus 1, root over minus 1 into root 2. Now this minus 1 I am representing with the letter I square. This minus 1 I am representing with the letter I square. So I square value is minus 1. Okay, na? Into root 2. So this is already, this formation is derived by the mathematician Euler. Okay? Right. So square and square root cancel here. That is equal to I into root 2 or root 2I. So root over minus 2 we are going to express as root 2 into I. That's why we are calling this root over negative numbers or imaginary numbers. Root over negative numbers are called imaginary numbers, where I square value is minus 1. I square value is minus 1. Okay, I square value is minus 1. What is the value of I cube? What is the value of I cube? What is the value of I power 27? Okay, let us see that also. So I cube value or I power 27, I power 56 like this. I cube is nothing but what? I into I. I into I square. In the place of I square, I can write minus 1 into I. Minus 1 into I is minus I. So I cube value minus I. And I power 4 value? What is the value of I power 4? I power 4 means up to I cube we got minus I into I. Minus I into I. So let us minus I into I value I square, and we know already I square value is minus 1. This minus is as it is, and I square value is minus 1. Minus into minus plus. So I power 4 value is positive 1. I power 4 value is positive 1. Okay na? I power 5 value is I. Again starting from I square, I cube, I power 4, I power 5 all. Okay na? Up to 4 it is repeating like this. Okay. In a such a way, I power 56. How can we write I power 56? We can write I power 56 as 4 into I power 14, right? 4 into 14, nothing but I power 4 into n. I power 4 into n. So nothing but I power 4 into I power 14. Can we write like this? Can we write like this? No. We can write it is I power 14 whole to the power of 4. A power m whole power n is nothing but A power mn. Okay na? So but I power 14 value how much? I power 14 value? I power 14 is equals to I power 4 into 3. 4 3 is 12 plus 2. Am I right? I power 4 into 3 plus 2. Now I power 4 into 3. I power 3 whole power 4 we can write. A power m whole power n formula, then only A power m into n. I cube value minus I, we know that. I cube value minus I, we know that. Whole to the power of 4. Whole to the power of 4. That means this plus 2 we rewrite that. Okay. I power 4 value how much? I power 4. I power 4 value 1. But minus I power 4 is came here. That means minus I into minus I into minus I into minus I. All are positives becomes I power 4. Again I power 4 value is 1 only. Okay na? 1 into I square. I square value minus 1. 1 into minus 1 is minus 1. Okay. So this I power 14 value we got minus 1. Minus 1 whole to the power of 4 is nothing but 1. So simply whenever you see this I power 46 is multiple of 4. I power 56, sorry. I power 56 is multiple of 4. We can simply write I power 56 value is 1. Okay? Check. Let us try to do I power 27 value. Okay na? I power 27. How can you write I power 27? We can write I power 24 plus 3. Can we write like this? Because 27 will not come in 4 table. I power 4 value 1 we derive it, right? So I power 24, only the multiple nearer to 27. Sorry, 28 also will come, but 27 is more. 28 is more than 27 now. So nearer value is 24. 24 plus 3. Okay na? So we can write that this is I power 4 into 6 plus 3. Can we write like this? I power 4 into 6 plus 3. So separate like A power m plus n is nothing but A power m into A power n. Same formula if I am applying here. I power 4 into 6 into I power 3. Bases are equal means we can add the exponents. 4 multiples means answer 1. And I cube value minus I. I cube value is minus I. I into I square, I cube value is minus I. So 1 into minus I is minus I. So simply I power 27 value is nothing but minus I. Okay now. What is I? I is nothing but imaginary value. And we have already discussed about the complex numbers also. Okay, now if a and b are any two real numbers, they can be expressed in the form of a plus ib. That such type of numbers are called complex numbers. We are representing with the letter z. Okay, now for representing I value, how we are taking that? I is the part of imaginary things. That means in square root of negative numbers, we are expressing in the form of imaginary values. For that, we are deriving that I value as this I square value is minus 1, I cube value is minus I, and I power 4 value is 1. These 4 we have to remember. I value is 1 as it is. I square value minus 1. I cube value is minus I, and I power 4 value is 1. These 4 we should remember. Then we can identify any value based on this. Okay, I power 500, I power 200, whatever we can find. Let us see that also once. Let us try to find the value of I power 57. Okay, or 55 we do. I power 55. How can you write 55 in the multiples of 4? 4 into 13, right? 4 13s. 4 10s are 40, 4 3s 12. Okay? I'll take 53, I'll take. 4 13s are 52 plus 1. Because 55 means like previously only we are getting that. IQ value will be getting. That's why I'm changing like 53. Okay. So this one I can express as I power 4 into 13 into I power 1. This value 4 multiples I power 4 is always 1. 1 into I power 1 means I only. So answer is I. So I power 53 value is I. Okay, now check. Yeah, in your textbook, I power 127 is given. Let us find the value of I power 127. Okay, now how to write 127? 127 in 4 table, 4 3s are 12, 4 1s are 4, 3 remains. That means I power 127 we can write as 4 into 31 plus remainder 3. That means I power 4 into 31 into I power 3. I power 4. Anything power 4 means I power 4 is always 4 into some any multiple, the value is always 1 into I cube. I cube value means I into I into I. I square value minus 1. I square value minus 1 into I. That is nothing but minus I. Okay? Because 1 into minus 1 is minus 1. Minus 1 into I minus I. That is the answer. Please note that. And also in the complex numbers, they are in the form of a plus ib, right? Where a is called real part. A is called real part, and this is called second part. This is called b is called imaginary part. Okay? Real part, imaginary part. Check. Next, let us do the complex numbers practice sheet. So, which are belongs to the complex numbers, and we learn that intervals, right? Intervals to absolute values. Based on that, we are going to find it. Okay. And if there are any binary system type of problems, we have discussed already. We'll do In case any other problems, we can, according to the concept, we'll discuss. Yeah, practice sheet here. First problem, modulus of x is less than a. We have learned the conditions at absolute value, whether it is less than a and greater than a. For less than a, we discussed that the x value lies between minus a and plus a. Okay, now if the modulus of x is greater than a, then x value is less than minus a or x value is greater than a. For the proof also we have discussed. Clear? Yeah, what is the question here? Modulus of x less than a. So answer will be minus a less than x less than a. Okay, now that is the first one answer. That is the first one answer. Next, second question. Second question also given the condition only. Modulus or modulo x or greater than a. Greater than a means answer is x less than minus a or x greater than a. Okay, na? We have already derived like this, right? Minus a here a. So x value is greater than x and less than a. Like this. This is the solution of x. For this first condition. For second condition, less than and greater than. Like this will be. That means it never between minus a and plus a. Okay. Next, third question. The third question is, if x and y are any two rational numbers, among them following statement is wrong. See, the first statement, modulus of x plus y is less than or equals to modulus of x plus modulus of y. One of the property we have discussed according to when we discussed about the absolute values. Okay, na? First property, mainly 2 or 3 properties we discussed. Modulus of x plus y, modulus of x minus y. For example also we have taken. So modulus of x plus y is less than or equals to modulus of x plus modulus of y. Same way, modulus of x minus y is greater than or equals to modulus of x minus modulus of y. Okay, na? So first option is true. Second option, x into y, modulus of xy is equals to modulus of x into modulus of y. That is also true. Sorry. And third question, modulus of x minus y. Third option is wrong. What is the third option? Modulus of x minus y is greater than or equals to modulus of x minus modulus of y. This is the actual solution, but it is given here less than or equal to. In the option less than or equals to is given. So that's why this option is wrong. This option is wrong. We are asked to find the wrong option. Question number 4. Modulus of x equals to a. X equals to a. Then a value. X is less than minus a or x is greater than a. X equals to plus or minus a. And third option is minus a less than x less than a. And last option, x belongs to minus a to a. Your answer is x equals to plus or minus a. X equals to plus or minus a. Because whenever it is less than and greater than symbols only, we are using these two conditions. Equal to means plus or minus a. Because modulus of negative value minus 5 is equals to 5. Modulus of 5 also 5. Both are having same now. X value whether it is positive or negative, you will get the answer like this same. Option 3, that one. Next, question number 5. Question number 5. That is modulus 3x minus 1 equals to 2. Then find the value of x. So here two values, same like in previous problem. Modulus of x equals to a means x value plus or minus a. So in the place of x, it is given 3x minus 1. So this 3x minus 1 also is equals to plus or minus 2. So I am separating like this, 3x minus 1, first I am taking plus 2 and 3x minus 1 equals to minus 2. So minus 1 is transposed that side, that is equal to 3x is equals to 2 plus 1. 3x value is 3 and x value is 3 by 3. 3 by 3 means value is 1. Here x value 1. Let us consider here second option. So 3x minus 1 transpose that side plus 1. Then minus 2 plus 1 will be minus 1 because 1 is negative, 1 is positive, answer is minus 1. X is equals to minus 1 by 3. 1 and minus 1 by 3 are the solutions. 1 or minus 1 by 3. Option 4. 1 or minus 1 by 3 is our required solution. Please note that. So next question is given based on the binary system. So we'll discuss all the binary system problems together to understand. So we'll go to the problem number 8. Okay, na? 6 and 7 are based on the binary system only. Now problem number 8, that is IM of 7 plus 5i. Here IM is nothing but imaginary part of this complex number. I told you already a plus ib or a plus bi, where a is called real part of complex number. We have to write like this: real part of complex number, and b is called imaginary part of the complex number. Okay, na? So from this number, what is that? Here a is equals to 7, b is equals to 5. Compare with this complex number general form a plus ib. Here real part is 7, imaginary part is 5. So our answer is 5. You are asking about the imaginary part now. So imaginary part is 5. Next, question number 9. The real part of 5 plus 7i. Real part of 5 plus 7i. So it is in the form of a plus ib. Then real part is 5. Imaginary part is 7. So real part is 5, imaginary part is 7. Next, question number 10. I power 225. I power 225. Let us try to write in 225 as the multiples of 4. So 4 5s are 20. 2 remainder, 5 down. 4 6s are 24. 1 remainder. That means we can write this one 225 as 4 into 56 plus 1. I power 4 into 56 plus 1. That is nothing but I power 4 into 56 into I power 1. So I power 4 multiples is nothing but 1. 1 into I power 1 value is I only. So 1 into I is I. Okay, now 1 into I is nothing but I. This is the answer. Next, question number 11. Let us see the question number 11 here. That is, not the 11, that means exercise 1. Exercise 1, first question. That is, the solution of modulus of x plus 1 is less than or equals to 6. Less than or equals to 6. Okay, na? That means it is in the form of modulus of x is less than or equals to a. Whenever it is less than or equals to a, we know that minus a, that means without the less than or equal to modulus of x less than a, we know that minus a is less than x less than a is the solution. But here r equals to is given means we have to take r equals to. Okay, na? Same way I am writing here, minus 6 less than or equals to x plus 1 less than or equals to 6. Minus 6 plus 6 between x plus 1. To find the solution, we need only x value. Where x plus 1 is there, so I am subtracting 1 from every part. Minus 6 minus 1, x plus 1 minus 1 and 6 minus 1. Minus 6 minus 1 becomes minus 7 less than or equal to plus 1 minus 1 cancel, x less than or equals to 7. Therefore, x is belongs to minus 7 to 7. R equal to means closed bracket. If there is no R equals to, we can use open bracket. That means x value is between these two, and sometimes it can be minus 7, sometimes it can be plus 7. Please note that. Sorry, here 6 minus 1 is 5, no? Sorry, 6 minus 1 is 5. Minus 7 to 5. Yeah, this is the answer. Option 2, according to your question, this is option 2. Now question number 2. The question number 2 is the solution of modulus of 3x minus 2, 3x minus 2 is equals to 10. If it is less than and greater than is different matter. Whenever it is given equals to 10, we have to take plus or minus 10. So that means without the modulus symbol, it will be plus or minus 10. So plus is one answer and plus 10 is one answer and minus 10 is one answer. Okay, na? Now 3x minus 2 transpose that side become plus 2. So 10 plus 2 is 12. X equals to 12 by 3. 3 table 12 4 times. One solution. Next second one. Minus 2 transpose that side plus 2. So minus 10 plus 2 is nothing but minus 8. So 3x value is minus 8 and x value is minus 8 by 3. Check. So answer will be minus 8 by 3 comma 4. First option. First option. Okay children, so that's it for today. Tomorrow we'll continue the class. Thank you one and all. Have a nice day. Bye bye.